Hi, I'm Matt Walker from Maths and Technology, and this is my FOSS4G 2013 10 Years After talk. I was involved in organising FOSS4G with a number of colleagues from Maths and Technology, including Joe Cook and Nat Scott. I was in particular responsible for organising the workshops. And this talk's to take you through some of the things that have changed since. We start with data. I think the general trend has been towards improved availability and visibility of data. Open data was very much a thing in 2013. OpenStreetMap have been around for some time and seen great adoption. The Ordnance Survey had released OS Open data a few years before, and I think we've seen a trend towards the Ordnance Survey and other public sector bodies releasing data since. More recently, Meta and Google have had projects releasing open data for public good. Things like Meta's Data for Good and the Daylight Map distribution on top of OpenStreetMap, and Google's Open Buildings project, which provides building footprints. And of course, there's a whole host of Earth observation data available. More recently, we've seen a move towards fair data principles, making data findable, accessible, interoperable, and reusable, really ensuring that the data that's available can be found and then used appropriately. And we've seen more of an emphasis put on use of metadata portals and APIs, so things like GeoNetwork and more recently the spatial temporal asset catalogs, which have popped up to allow people to get hold of Earth observation data primarily, but in future also of the geospatial data. A lot of the work that I tend to do is publishing data on the web, and I think I'd sum up the changes there as the geospatial technology is really working along the grain of the web, working with the web technologies appropriately. We've seen a whole host of new formats: cloud-optimized GeoTIFF, point cloud, shapefile, flat GeoBuff, vector tiles, and more recently projects like ProtoMaps, which look to make vector tiles cheaper and easier to serve. In the web mapping world, we've seen great improvements from libraries like OpenLayers, Leaflet, Mapbox.gl, and more recently MapLibra. And here we're seeing the tools leveraging modern JavaScript, so allowing you to use modern JavaScript build processes to build your applications, and also definitely leveraging the modern technology that's available in users' web browsers, from Canvas to WebGL, and even now up to WebGPU, which is a new technology that's currently being previewed within Chrome. The OGC have revamped the APIs that we know and love, so WMS, WFS, WPS, all of those are being replaced by more modern APIs that are RESTful, use an open definition of their capabilities, respects HTTP status codes, all these good things, so that they really work with existing web tools and more easily integrate with the wider ecosystem. The cloud's been a trend, certainly, and there is some benefit of running your processor on someone else's computer. Both Amazon and Microsoft support PostGIS and other related geospatial tools and extensions within their cloud environment. They've even gone as far as having whole offerings like Microsoft Planetary Computer, which is an implementation of the spatial temporal asset catalog. Amazon have their location service for building geospatial applications on top of their platform. And if you're interested in reading a bit about how these organizations contribute back to the open source community, or perhaps not as much as we might like, then Paul Ramsey has written a couple of very interesting blog posts. On the data science side, yeah, something about classic GIS analysis, but more mainstream. So we've always done data science or analysis within GIS. It kind of underpins the discipline. But increasingly, we're seeing a move towards a more scripted use of analysis, so using Python, R, or JavaScript. In the Python world, there are fantastic libraries on top of the Python core, like Pandas for doing analysis, GeoPandas, which provides geospatial analysis on top of that, and Moving Pandas for doing analysis of moving objects. And we're seeing spatial support on top of things like SQLite and more recently DuckDB, which now has pretty decent spatial support for to do filtering and joining of geospatial data alongside other data. while doing data science type work. I think a talk like this would be amiss not to mention AI and machine learning. A lot of talk about large language models and the likes recently. There's been quite a lot of activity in the Earth observation remote sensing world. There are various Python libraries and others that allow you to provide classification of geospatial data. There's a really interesting project, Machines Reading Maps, which looks to extract text features, make those indexable, predominantly out of historic maps. A nice one to look at. And then also tools like the OSGeo, which look to allow you to provide natural language description of the features that you want to say, extract out of OpenStreetMap, and it will write the overpass filter language to then extract those for you. Main takeaway I've had so far from AI is to make sure that the results are QA'd. Make sure that the results that are given by a given process are actually fit for purpose before just running away and using them. And I thought I'd end on some market leaders. So PostGIS and QGIS, they were definitely around in 2013. We had plenty of workshops, plenty of talks on both. And I think it's just fantastic to see that they've both continued to thrive as projects. And I think truly can be thought of as market leaders within the geospatial community overall, not just the open source community. They're very reliable and feature rich, very wide adoption these days, and they continue to improve. Real success story within the open source world, with lots of organizations both using and contributing back to those two projects. Thanks for listening. It's a bit of a cook's tour through what's changed. Be really interested to hear what you think and what you might be looking forward to in the next 10. Thank you very much.